All right, just because I love you, I'm going to make some word problem examples for you because I know you love those so much. All right, so this one says, to raise money for Boy Scout camp, Alec is selling popcorn. He sells small bags of popcorn for $4 and large bags for $6. He needs to earn at least $300 to attend camp, and he also will earn a badge if he sells at least 60 bags of any combination. So let's take a look at what we're going to do here. So first, let's define our variables. So let's say small bags of popcorn is going to be S. So that would be the number of small bags that he sells. Okay. And let's do large bags as, let's do it as a B because L is just, looks too much like a 1. So B is the number of large bags of popcorn that he sells. So let's define some inequalities. Well, first we know that he needs to sell at least 60 bags to get his badge. So the number of small bags plus the number of large bags needs to be greater than or equal to 60. So the number of small bags, which is S, plus the number of large bags, which is B, needs to be greater than or equal to 60. Because this says at least 60, so he gets a badge if he sells 60 or more bags. Okay? Now, the other constraint we have here is that he sells them for $4 for a small bag. So when he sells a small bag, he makes $4 times however many he sells. And large bags, he sells for $6. And so when he sells those, he makes $6 times however many bags he sells. And he has to sell at least $300, which means the price for small bags plus the price for large bags added together should be greater than or equal to $300. So here is our system of linear inequalities. Now let's graph these. So our intercepts are going to be, let's see, when S is equal to 0, B is equal to 60, and when B is equal to 0, S is equal to 60. So let's do a scale factor of like 5 on these. So let's do 10 and 20 and 30, 40, 50, 60, 70. So if that's 0, then this is going to be 10, 20, 30, 40, 50, 60, and 70. All right, now let's define one of these variables as the horizontal axis and one is the vertical. Again, these aren't independent or dependent necessarily, so we can define either one. So let's say this is our small bags and this is our large bags. Okay. Now, if he sells 60 small bags and 0 large bags, then that works, right? He can sell 60 large bags and 0 small bags. He could also sell 60 small bags and 0 large bags. Is that what I said? 60 large bags and 0 small bags. That also works. Those are our intercepts for this line. So let's go ahead and graph that one. And we want to sell more than 60, right? So if he sold 65 small bags and 0 large bags, that works. But if he sold 0 of each of them, that doesn't work. That doesn't satisfy our inequality. 0 plus 0 equals, or is not greater than or equal to 60. So we're going to shade above this line for that one because we want to sell more than 60 bags. And all of these points over here would be more than 60 bags. Okay, now let's take a look at the other constraint. So if he sells, what are our intercepts for this one? Well, when he sells, if he sold just small bags of popcorn, how many bags would he have to sell to get to 300? Well, at $4 a piece, that would be, this was equal to 0, so we would have 4s equals 300. Divide both sides by 4. He would have to sell at least 75 small bags to get to $300. So if he sold 0 large bags and just small bags, he needs to sell 75 of them. So this point would work to get to his $300. Now, if he didn't sell any small bags at all and only sold large bags, how many would he have to sell? Well, that comes out to 50, right? Because we end up with 6b equals 300. Divide both sides by 6, and b is going to be equal to 50. So if he sold 50 large bags and no small bags, that would be right here, then that also works. That also satisfies that constraint. And then any combination on this line also works to give him exactly $300. But here's the thing, we don't have to just sell $300. We can sell more than $300 if he wants. So he can sell anything greater than this line, and it would still give him his $300 that he needs to sell. So at what points are both of our constraints met? At what points has he sold over $300 and over 60 bags? Well, above this red line in this red shaded area, he has sold over 60 bags, but not necessarily 300. And over this green line, he has sold over $300. So where these two meet, he has sold over $300 and over 60 bags. So this little triangle here and this little triangle here, those don't work, because in here he has sold over 60 bags but not 300. In this place he sold $300 but not 60 bags. And so this entire region, our answer is just this graph of possibilities. And so the next question says, using your graph, give 2 possible combinations of bags of popcorn that Alex can sell to attend camp and earn his badge. Well, you could pick literally any point in here, and because these lines are solid, you could pick a point on the line as well. But let's pick this point right here. This point is inside of our shaded region. That's 40 small bags and 50 large bags. 40 small and 50 large. And if we figure that out, 40 small bags times $4 each gives us $160. And 50 large bags times $6 each gives us $300. So he's sold $460 worth, and he's sold 90 bags total, so that point works. Okay? We could pick any point also. We could pick a point way out here. I mean, you know, that's really reaching for the moon for his marketing strategies, but that might work. Or we could pick a point like right here. Again, literally any point in the shaded region works. So this point is at 10 small and 60 large. Again, that's 70 bags total, so that meets this constraint. It's definitely over 60 bags. And if we did $40 for the small bags, and then he'd get $360 for the large bags, he would actually make $400 total, and that's over the $300 limit. So any point in here you could have picked, and I just happened to pick this point and this point to satisfy these 2 constraints there that we wrote.